Welcome everyone. Imagine walking into a factory in 2026 and seeing robots that look remarkably human, assembling products, packaging goods, and even inspecting quality control lines. This isn't science fiction, it's happening now. The revolution is being driven by general-purpose humanoid robots, AI-powered machines designed to handle a wide array of factory tasks that once required human workers. These aren't stiff, pre-programmed machines limited to a single task. They are adaptable, mobile, and intelligent, and they are reshaping how factories around the world operate. Leading the charge are companies like Tesla, with its Optimus robot and Figure AI, which has been gaining significant attention for its fully autonomous humanoid workers. Unlike traditional industrial robots bolted to the floor, these robots walk, grip, and analyze their surroundings. They use machine learning to adapt to new tasks without needing to be reprogrammed manually. In just the past year, several successful pilots have shown these robots performing warehouse picking, assembly line support, and basic packaging tasks alongside human co-workers. One of the key innovations enabling this transformation is AI-powered vision and motor control. Using advanced computer vision systems, these robots can identify objects, read labels, and navigate dynamic environments. They learn from thousands of hours of video and simulation data, gaining the ability to understand context and anticipate movement. This is paired with motor skills controlled by neural networks, allowing for fluid movements, object manipulation, and responsive adjustments in real time. These systems are no longer just automated arms, they mimic the flexibility of human hands and bodies. Tesla's Optimus robot is a prime example of this shift. Originally unveiled as a concept, it has rapidly matured into a functional prototype capable of lifting boxes, sorting items, and walking unaided through factory floors. Tesla aims to integrate Optimus into its gigafactories by 2026, where it will handle repetitive and physically taxing tasks. Elon Musk has stated that Optimus could be more valuable than Tesla's entire automotive business in the long run, with applications extending far beyond the factory. Figure AI has taken a slightly different approach. Its humanoid robot is designed from the ground up for general-purpose factory tasks. The Figure 01 model features a fully articulated body, human-level dexterity, and autonomous decision-making capabilities. It operates using a closed-loop AI system that continuously evaluates its performance and adapts in real time. Figure has already partnered with several manufacturers to begin testing the integration of these robots into active production lines. These pilot programs suggest a fast-moving shift toward robotic labor at scale. One of the critical advantages of humanoid robots is their ability to work in environments built for humans. Unlike traditional robots that require customized infrastructure, humanoid robots can navigate standard walkways, use existing tools, and even operate machinery designed for human hands. This drastically reduces the cost and complexity of automation. Factories don't need to be redesigned. The robots adapt to the factory. That makes them attractive to mid-sized and smaller manufacturers who might not have the budget for a full robotic overhaul. General-purpose robots also bring a new level of flexibility. Traditional automation is rigid. Machines are configured for one task, and reconfiguring them can take days or weeks. AI robots, however, can be retrained or instructed through simple demonstrations. With reinforcement learning and imitation learning, a human can show a robot a new task, and the robot can begin practicing it immediately. This makes production lines far more responsive to market changes. Need to switch from one product model to another overnight? AI robots can handle that. The role of AI in this revolution extends beyond motor functions and sensors. These robots are beginning to understand language. Integrating large language models like those used in ChatGPT, some prototypes can take verbal instructions from supervisors. A manager might say, "Stack these crates in order of expiration date," and the robot can pass the command, plan the task, and execute it. This capability reduces the need for specialized programming and makes the robots more user-friendly on the shop floor. Data is another asset driving the factory robot revolution. Every action performed by an AI robot is logged, analyzed, and used to improve future performance. Fleet learning allows multiple robots across different locations to share updates. If one robot learns a more efficient way to stack pallets, that improvement can be shared across the entire network instantly. It's a form of collective intelligence that grows stronger over time, with every task performed making the entire system smarter. There are workforce implications too. Rather than displacing all human jobs, many experts believe these robots will take over the dullest, most dangerous, and most repetitive tasks, freeing humans to focus on roles requiring creativity, judgment, and complex decision-making. In this hybrid model, humans and robots collaborate. Humans act as supervisors, trainers, and integrators. Some companies are even developing training interfaces where human workers can guide robots through virtual reality environments, teaching them tasks remotely. Of course, the rise of humanoid robots raises questions about labor economics. If a robot can do the work of multiple humans without taking breaks, what happens to labor demand? The answer may lie in new economic models. The cost of goods could decrease as production becomes more efficient, and new roles may emerge in robot maintenance, oversight, and development. Governments and educators are watching closely, considering how to reskill workers for a robotic age. The timeline for widespread adoption is closer than many expect. Analysts project that by 2026, thousands of general-purpose humanoid robots could be deployed in factories globally. Early adopters include electronics manufacturing, automotive assembly, and logistics centers. These industries are ideal testing grounds due to their structured workflows and high demand for labor. Over time, more sectors, from food processing to home appliance assembly, will follow suit. Hardware improvements are accelerating this trend. Battery technology, lightweight materials, and improved actuators are making robots more agile and efficient. Some prototypes can operate for 8 hours on a single charge, matching a human shift. Others are designed for modular repair, meaning worn-out components can be swapped quickly on the factory floor without sending the entire unit back for service. These practical upgrades are what make large-scale deployment feasible. A few companies are even exploring subscription models for humanoid robots. Instead of buying a robot outright, a factory might lease them monthly, receiving software updates and maintenance as part of the package. This model lowers the barrier to entry and spreads the cost over time. It also ensures the factory is always using the latest version of the robot's AI brain, benefiting from the constant upgrades in capability. There are also safety protocols being developed to ensure that these robots can work safely around humans. Proximity sensors, fail-safe mechanisms, and predictive modeling are all used to prevent accidents. In some factories, robots are taught to pause or adjust their movements if they sense a human stepping into their workspace. These safety layers are essential for public acceptance and regulatory approval. As we move toward 2026, collaboration between robotics companies and factory operators will shape the pace and scope of adoption. Trials are underway to test how robots can be seamlessly introduced without disrupting existing workflows. Some factories are starting small, assigning robots to a single task like sorting or transport. Others are more ambitious, aiming to replace entire shifts with mixed robot-human teams. Success in these trials will determine how quickly we see full integration. Public perception also plays a role. If robots are seen as replacing jobs, backlash could slow adoption. But if they are marketed as tools that empower workers and improve safety, acceptance will grow. Communication and transparency will be key. Factories implementing AI robots are increasingly offering tours, publishing results, and sharing success stories to build public trust. Looking ahead, the future of factory automation will not just be about machines doing human work. It will be about machines enabling humans to do more meaningful, skilled, and creative tasks. AI robots are not the end of the workforce. They are its evolution. With careful planning, inclusive design, and ongoing dialogue, the factory floor of 2026 may be one of the most productive, safe, and advanced work environments ever created. Thank you very much for watching. Please like and subscribe.